Figure 16.4, stack unwinding. When an exception occurs in your program, the default thing that happens is called stack unwinding. And basically what that means is there's a chain of function calls that led to the point where the exception occurred, and those function calls are on the function call stack. And what we do is we basically terminate each function that was called in sequence, unwinding the function call stack back to an earlier point in the program where eventually we hope to get to a point such that the exception can be caught and handled and allow us to continue executing normally. Now, the default action is if you don't ever catch an exception that occurs, the program will actually terminate with a call to the cstdlib header files abort function. And that's simply going to terminate the program immediately, and of course at that point you have no way to handle what the problem was that occurred, and your program is not very robust, and depending on the platform you're running it on, you may or may not get any kind of error message indicating something went wrong. So what we want to do here is demonstrate this concept of stack unwinding, and also another benefit of this mechanism is that it gives you the opportunity to decide where you want to handle exceptions within your code. So in this example, we have a main function and three other functions called function1, function2, and function3, and we're going to call them in a chain. And to demonstrate that chain of function calls, I'm going to use the debugger in this program, and I've set a breakpoint here at line 39 in main, and I'm going to go ahead and run the program. And within Visual C++, one of the windows that we have available to us in the debugger is the so-called function call stack window, or call stack window, which in Visual C++ you can get to via debug, windows, and call stack. Now, other debuggers in other environments will also have similar windows. And the main thing we're using this for here is just so that we can show you that main has been called so far, and then we want to see this function call stack build up as we call the other functions in the program. So what I'm going to do is I'm going to step over my output statement, which is going to then display in the output window. Whoops, let's get rid of that. The window hasn't been displayed yet. This is going to display the words function1 is called inside of main. Then we're going to step into the function1, and we're going to use this step into command or F11 key to do that in Windows. And when we do that, we can see now that the function1 is on the call stack above main. Remember, it's a stack, so the next item added is placed on top of the stack. Now let me just scroll up a little bit here so you can see the whole function1. And with function1 here, we have a new feature. We're indicating that function1 might throw a runtime error. And basically the idea here, this is called an exception specification, and it's a hint to client code programmers saying if you call this function, you might get back a runtime error. Therefore, you should wrap any calls to this function in a try statement. And that's what we did down here. Function1 was called from a try block. Now, because this function might throw a runtime error, you look through the code and you're looking for a throw statement, and you don't see anything here. Well, just because a function says it throws a runtime error doesn't mean that the code that actually caused the problem is inside of this function. It could be in some other function that was called from here. And in fact, that's the case in this example. So what I now want to do is continue stepping, and I'm going to step over my cout statement. Then I'm going to step into function2. Now we see function2 on the call stack. Function2 also indicates that it might throw a runtime error. It doesn't show any code that appears to be doing that here, so the code that's doing it must be in function3. So if I step over my cout statement and into function3, we can now see the function call stack, which started with main, then we called function1, then we called function2, then we called function3. So we're 4 levels deep in our currently executing application. And for function3, we also once again have an exception specification saying this function might throw runtime errors. By the way, you can have a comma-separated list in here if you want to indicate multiple potential problems from a given function. Now in function3, we're just going to print out that we're in function3. Then we're actually going to throw an exception. So if I step down over the cout, and now I step over the runtime error throw statement, you can see that it immediately jumped all the way back to main and the catch handler in main. And basically what happened here is that the exception that occurred happened in function 3 and not inside of a try statement. So function 3 terminated. The exception was returned back to line 23 where function 3 was called. That was not in a try statement, so function 2 terminated, and the exception was returned back to where function 2 was called here at line 30. That was not in a try statement, so function 1 terminated, and the exception was thrown all the way back to line 40 in main. Then, because that was in a try statement, the try statement block of code terminated. If there were any code in between lines 40 and 41, it would not have executed, and then the catch started executing to print out for us that the exception occurred and that the exception was handled in main. And if I go ahead and stop there, then let's see if it actually, well, unfortunately the window's not being displayed here at the moment, but let me run the program from scratch to show you what happens with the output window. And you can see that function 1 was called from main, function 2 was called from function 1, function 3 was called from 2, and then we were in function 3. That's where we threw the exception, and you saw that there was no code to handle that exception in function 3, function 2, or function 1, but we did eventually catch the exception and display its error message and indicate that it was handled in the function main. Now, because of the chain of function calls that we had here, we could have caught the exception right where it was thrown, which you don't normally do. We could have wrapped line 23 in a try block and then had a catch handler following it at line inside of the function 2, so we had an opportunity to catch it here. We just didn't take advantage of it by writing the appropriate code. We had an opportunity to catch the problem in function 1, but again we didn't write a try-catch sequence, and that's because we decided in this example that we really just wanted to catch any problems that occur in main and display an error message before the program terminates. So you have the flexibility of deciding the different levels, if you will, throughout the call hierarchy where you might want to do the handling of an exception.